Is Tuesday, March 28th, 2017, and I'm heading into work here at 4 in the morning. That's fun. At least it's not so cold. Used to be walking in. It's just a real exercise in endurance, but things are better. Let's get started today by digging into some science. We'll start making some microfluidic chips, and we'll walk through that process. Just checked the weather on my way into the lab, and it's actually 4 degrees Celsius outside today, or about 37. So by my standards, that's just not even cold anymore, which says something about my standards, I would say. Been a long couple of years since Texas. Oh. But here we go into the lab. Let's have a look at that laser cutter. What you'll notice is there's that big blue hose coming off the back. Not too long ago, some hobbyists managed to kill themselves using the exhaust out of one of these laser cutters into a closed room. So it's really important to be well vented. The stuff that comes off them is not dangerous if it's in a nice, well-ventilated environment, any more than, say, spray paint is dangerous in a well-ventilated environment. But still, we do need to keep our environment well-ventilated. So I'm going to make 4 different cuts. This is the first cut. I just make little circles that cut the through holes for the fluid connections. And once I've got the through holes cut, I cut the channels. The channels are cut at a much faster rate. You can see that the laser head is moving more rapidly, so that makes a shallower cut. Now the software is kind of dumb, so I have to cut the channels in 2 separate layers, or else it tries to recompute a stupid tool path. So once I have the channels and the through holes cut, then I cut out the final chip, and I make another chip the same size with just a flat piece of plastic to seal down onto that and make enclosed channels. For the sake of brevity, I'm going to skip the part where I mash it in a heated press to seal the channels, and we'll just take it straight over and rig up the fluidics. We have rigged it up on the microscope. Let's go have a look here. So there it is. And if we want to look at the actual droplets, we need to get the microscope up and running. So here's a movie of that. So what we're looking at is oil flowing from the left and right hand channel, and water dyed blue flowing from the upper channel. And they're all converging, and the water breaks up into nice little droplets. There's also a little out of focus lump of water up in the center of the T, which is a little weird. I think it's just an artifact of the way that I cut the channels, but it's something I need to be aware of that I can work on later. So the whole point of all this was to make smaller channels that would then make smaller droplets, but these particular channels are not actually a lot smaller than what I had yesterday. If anything, they're a little bigger. So that's a little disappointing, but the droplets are still easy to make, and they're coming along nicely, so we'll call that a marginal success. From start to finish, that process took about 2.5 hours, from cutting the chip to sealing it to running fluid through it and getting some data. So that makes me happy, because I like to have the design, build, test, feedback loop be as short as possible. I know my students are busy and frustrated that things don't work as fast as they could, so anytime I can make the process shorter, I'm happy. So that's it for today. Tune in tomorrow. We'll talk more about droplets and microfluidics and chemistry and science, and maybe we'll even get some smaller droplets here in the Allen Lab.